Under India's Digital Personal Data Protection Act, a company is designated as a significant data fiduciary based primarily on scale. The law evaluates the sheer volume of personal data processed, alongside the breadth of risk, to decide how strictly an organization must be governed. The statute applies this volume-based standard uniformly across all industries. It deliberately abandoned the category of sensitive personal data found in earlier Indian rules, refusing to place health records on a special regulatory pedestal. Commercial entities typically treat data as money. Within a clinic, that same data represents the patient's physical well-being. Data here is life. When a data breach occurs in a corporate environment, the fallout is measured in financial loss and privacy violations. In a hospital, a compromised system or altered diagnostic file instantly crosses the threshold into immediate biological endangerment. Because the legal statute declines to elevate health data based on clinical risk, the responsibility of restoring the special status of patient information falls entirely on internal institutional frameworks rather than the government. Measuring clinical risk with commercial compliance metrics leaves hospitals dangerously exposed. Addressing this gap requires a specific governance overhaul. This diagram illustrates the first generation of data perception. Early on, personal data was understood technically as raw binary bits. Protection meant securing those bits. The primary concern of that era was maintaining confidentiality, integrity, and availability, the standard CIA triad of information security. In the second generation, organizations began viewing data as a highly monetizable asset. Digital marketing companies built their operational models around profiling users and linking those profiles directly to advertising revenue. Modern privacy legislation, including the DPDPA, emerged entirely as a response to this second generation. The laws were designed to regulate data as currency and enforce measurable obligations around user consent. The third generation centers on the clinical environment. In this setting, patient records reflect a biological state, distinct from their previous status as a tradable commodity. The concept of data valuation does not disappear in this phase, but its denomination changes. Data valuation remains the core of healthcare compliance, though the denomination has changed. We now measure the value of information by the severity of potential clinical harm. This animation shows the inherent flaw in applying the DPDPA's metric of significance to a clinical setting. Harm to biological life is an absolute metric. Unlike commercial loss, the loss of human life cannot be realistically graded by data volume. A systemic data breach at a massive corporate hospital chain and a targeted breach at a small local nursing home carry the exact same biological weight for the patients involved. The risk reaches perfect equilibrium. Endangering a single patient through compromised medical data is a compliance failure equal in gravity to endangering 1,000 patients. To address this gap, the Data Governance and Protection Standard for India, or DGPSI, established a corrective mandate that bypasses standard government notification thresholds. Under this framework, every single hospital is rigidly categorized as a significant data fiduciary, regardless of its facility size or its daily patient count. Discarding the volume-based scale fallacy is the necessary first step to engineering an architecture capable of actually protecting patients. This diagram depicts a standard lean corporate compliance model under the DPDPA, operating beneath an independent director. It relies on two primary roles. The Data Protection Officer, or DPO, handles privacy obligations, notices, and legal processing. The Chief Information Security Officer, or CISO, focuses on securing the physical network architecture. A healthcare facility cannot rely on this simplified dual-officer structure to manage its liabilities. It requires a mandatory third node, the Patient Safety Officer. This role is tasked specifically with governing clinical risk and medical liabilities arising from adverse hospital events. The Patient Safety Officer holds a quasi-legal authority that directly protects the hospital and its medical staff. Because a data failure often translates into a clinical failure, this function cannot be subordinated to the privacy mandate of the DPO. Recognizing these governance sensitivities, the framework institutes a triumvirate structure. The DPO, CISO, and PSO function together as a unified compliance subcommittee beneath the main apex governance body. While they coordinate internally, Each officer maintains a distinct external line of exposure to their respective regulatory authorities. Replacing a traditional linear hierarchy with a collaborative triumvirate matrix is the only structural method for a hospital to manage these overlapping high-stakes liabilities. We can observe exactly why this architecture is necessary by pressure testing it against a live data breach scenario. A single compromised hospital server immediately fractures regulatory obligations, triggering multiple institutional clocks that are distinctly out of alignment. This animation maps the alert vectors. The first statutory clock belongs to the CISO, who faces a grueling mandate to report the cyber incident to CERT-IN within exactly 6 hours. Simultaneously, the second statutory clock activates. The DPO is required to notify the Data Protection Board and all affected patients within 72 hours. Because diagnostic data may have been tampered with, a severe clinical safety event is activated at the exact same moment, requiring the PSO to coordinate with accreditation authorities like NABH. Attempting to manage 2 rapid timelines, 2 separate regulators, and distinct reporting formats generates immediate administrative chaos. The triumvirate prevents institutional paralysis. It functions as a centralized coordinating engine, allowing the 3 distinct officers to execute their specific reporting duties in parallel without duplicating efforts. Leaving even one officer out of this matrix ensures the regulatory clocks will expire, while the remaining team scrambles to stitch a fragmented response together. This structural baseline prepares hospitals for the next operational reality, the rapid adoption of artificial intelligence in clinical environments. AI-assisted diagnosis and clinical decision support models blur the historical boundaries between IT network security and patient safety. An inherently biased profiling algorithm or an erroneous diagnostic data model poses the exact same biological threat to a patient as an external malicious data breach. Governing these advanced systems requires the combined safety lens of the PSO, the security lens of the CISO, and the privacy lens of the DPO acting on a single model. This synthesis represents the final evolution of this framework, DGPSI full, with AI. Institutional frameworks must formally treat clinical data as life, precisely because the baseline statutory laws currently fail to make that distinction. Hospital compliance is fundamentally an architectural challenge. Ultimately, securing the biological patient is now completely synonymous with securing their digital data.